Chapter 9 Carbonyl Compounds. There are 4 subtopics in this chapter. In this video, we are going to cover 9.1 Introduction and 9.2 Nomenclature. At the end of the lesson, students should be able to first give general formula of aldehyde and ketone, and second, draw structures and name aldehydes and ketones for the parent change of carbon less or equal to 10 according to the IUPAC nomenclature. Introduction. The functional group for carbonyl compounds is carbon double bond to oxygen. The general formula is CnH2nO. For example, if we have 4 carbon, then the number of hydrogen will be twice, which is 8. Aldehyde and ketone are isomeric, which means they have the same general formula. And carbonyl compounds are polar compounds. However, in general, an aldehyde is more reactive than ketone towards nucleophilic addition reaction. For an aldehyde, the structure is as follows. The carbon double bond O is in between hydrogen and R group. The R group is alkyl, aryl, or hydrogen. For ketone, the structure is as follows. The carbon double bond O is put in between 2 R groups. The R groups are alkyl or aryl. Nomenclature. For an aldehyde, they are named by substituting the letter E of the corresponding alkane with al. Basic name depends on the longest change with CHO group. The change is numbered by starting with CHO group as carbon 1. The following table shows the structure of common aldehyde, their common names, and their IUPAC name. For example, the first structure is methanol, with the common name is formaldehyde. Next, we have ethanol, and the common name is acetaldehyde. And the last one is phenylmethanol, with the common name benzaldehyde. Let's look for example to name an aldehyde. In the following example, the first carbon is the carbon that attach double bond to oxygen and hydrogen, followed by the next carbon 2, 3, and 4. Since we have 4 carbon change, the parent name will be butanol. And if we look at the structure, we have double bond at carbon 3. So the name will change into 3-butanol. Butanol means there is double bond at carbon 3. Next example, as usual, the first carbon is the carbon with CHO group, and next is the second carbon. Since there is 2 carbon change, the parent name will be ethanol. And if we look at the structure, there is a benzene ring attached to the second carbon. Benzene ring as a substituent is called phenyl. So, the name would be 2-phenyl ethanol. Next, as usual, we numbered the carbon change first and we will get 4 carbon change, which means the parent name is butanol. If we look at the structure, we will have ethyl group at carbon 2 and hydroxy group at carbon 3. So, the substituent is written as 2-ethyl 3-hydroxy-butanol. Okay, last example for aldehyde. Firstly, we numbered the carbon change 1, 2, 3, 4, 5, 6. There is 6 carbon change, which means the parent name is hexanol. If we look at the structure, there is double bond at carbon 5. So the name hexanol will change to 5-hexenol. And there is bromo group at carbon 4 and cyclopentyl group at carbon 3. So the substituents is written as 4-bromo, 3-cyclopentyl, 5-hexenol. Next, we look at the nomenclature of ketone. Ketone is named by substituting the letter E of corresponding alkane with -one. For example, we have propane on the left side. If we change the E into -one, the name will change to propanone. Second example, we have butane on the left side. So, the name butane will change to butanone for the structure on the right. Next, we have cyclopentane on the left side, and to change it into the name for ketone, it would be cyclopentanone for the structure on the right. The longest change with carbonyl group is numbered so that carbon in carbonyl groups gets the smallest number. For example, if we look at the following structure, if we number the carbon change starting from the left, the carbon double bond O will get the number 4. But if we number the carbon change starting from the right, the carbon double bond O will get the number 2. So, to name this ketone, we will use the numbering from the right. And we will have the name as pentane 2-one or 2-pentanone. The following table shows the structure of common ketone, their common name and their IUPAC name. The first structure is propanone, or its common name is acetone. The second structure is butanone, or the common name is methyl ethyl ketone. The third one is pentane 2-one, or the common name is methyl propyl ketone. Next, we have pentane 3-one, or the common name is diethyl ketone. Next, phenylethanone, or the common name is acetophenone, and the last one is diphenylmethanone or diphenyl ketone. Let's look for some example. The following structure is numbered from the left. So, we have carbon double bond O at carbon 2. So, the parent name would be propane 2-on. We have cyclopentyl group attached to carbon first, so the substituent is written as 1-cyclopentyl propane 2-on. Next example, we numbered the carbon from the left, and we will get carbon double bond O at the first carbon. The carbon change is 3, which means the parent name will be propane 1-on, indicating that the carbon double bond O is at the first carbon. We have also cyclopentyl group attached to the first carbon, so the substituent is written as 1-cyclopentyl propane 1-on. That's all for this video. Thank you.